In this video, I'm going to talk about one of the most fundamental things about chemistry, and that is, what is a chemical reaction exactly, right? Like, you all have heard the word chemistry, you grew up hearing it, and probably what you think of is people in lab coats mixing colorful liquids with different pieces of glassware, Um, but really, do you understand what is and isn't a chemical reaction? Probably not. So that's what this is about. Now, chemical reactions are also called chemical changes, and things that are changes that are not chemical reactions, those are called physical changes. So physical and chemical changes, those are opposites. And the key difference here, I'll just cut to the chase right away, is that when there's a chemical reaction, it makes a new chemical. Okay? You create a new substance. So definition. A chemical change creates a new substance. Okay, and what I mean by that is, whatever substance you started with, it goes through this chemical change, and that irreversibly usually changes that into a whole new substance. The atoms in the original substance rearrange, chemical bonds are broken, new chemical bonds are formed, and what you get out the other end of that chemical reaction is fundamentally different from what you started with. How do we know when a new substance has been created? And before I get to that, I'm just going to take a look at a few pictures here. Like, here are some common chemical reactions that you see in normal life. Okay, it's fall right now. As I shoot this video, the leaves are changing color. That's a chemical reaction of the chlorophyll inside of those leaves. Rusting metal is a very slow chemical reaction, but again, that metal is fundamentally changing into a different substance. It's not the shiny, hard metal it used to be. It's this crumbly, not shiny, rough orange stuff. Rust is a different chemical. Fire, right? You start with a piece of wood in your fireplace, and when that fire reaction, chemical reaction, is over, it's not a piece of wood anymore. Now you have ash, you have smoke. It's the wood has been transformed into many other different chemicals. Okay? So this begs the question, well then, how do I know, Mr. Stockinger, how do I know if a new substance has been created? Because it's not always easy to tell, right? Like ice, if you melt ice, you used to have ice, but now you have water. Is that a new substance? Well, no, it's not, actually. Another one is dissolving. If I take this medicine tablet and dissolve it into the water, it looks like it disappears. But again, I'm not actually making a new substance. And sometimes it's hard to tell, even though it looks like this salt is becoming something different, like it's becoming liquid. It's really not. So what clues can we use to figure that out? Clues of chemical change. Color change. Almost always. In all of these chemical reactions down here, there is a color change, right? The color of ash is not the same as the color of the original wood. In these physical changes here, not really a color change, okay? Clear colorless to clear colorless. Maybe a little color change here, but not really. Like, I didn't create any color. I just took a white salt and dissolved it in the water, and then it's clear. Okay, so when you see a color change, that's often a good clue. Formation of a gas. Sometimes when you do a chemical reaction, gases are created. Like in the fire, it creates smoke. That's a new gas. That's formation of a gas. Note that this one isn't foolproof. When you boil water, you're creating steam, you're creating water vapor, a gas, but that's not a chemical change. Okay, again, because when you boil water and you create water vapor, it's still water. You can go backwards and condense it back into water. And that brings me to a third clue. If it's a chemical change, usually it's irreversible. Right, leaves changing. Can you get them to go back to green? No. Once they change color and then get brown and crumbly, that's the end of those leaves. The tree has to make all new leaves next spring. Can you unrust a piece of metal? No. You can remove the rust that's on the surface and see some new metal underneath, but you can't take the rust itself on the surface and turn that back into metal. Can you unburn a fire and turn that gas, smoke, and ash back into a log? No, you cannot. Can you unmelt an ice cube? Sure you can. That's called freezing. Okay, so another clue that this is not a chemical reaction, it's a physical change. Can you undissolve a salt tablet from water? You may think the answer is no, but actually yes you can. If you boil away or evaporate away the water from that glass, there will be a film of that salt left on the bottom. The salt won't float away. It will stay in the bottom of the glass. So you can separate out the salt from the water again after dissolving has happened. Chemical changes, irreversible. Physical changes, almost always reversible. Again, not always, but that's a good clue. And any other evidence that you have that a new substance was created, that's what you're looking for. And it's as simple as that.